Oh, it's already up there. Well, hello everyone. Today I'm going to be talking about common VoIP problems, how to detect, correct, and avoid them. My name is David Attias, or Samuel David Attias. I've been I've been installing VoIP systems for 7 years. I've been a MikroTik user for 5 years, and I currently hold the MikroTik certifications of MTCNA, MTCRE, and MTCWE. I've also been in the IT industry for 20 years. So the purpose of today's lecture is going to be to inform MikroTik users on how to identify and resolve VoIP problems. This lecture is going to be a lecture-style presentation, more like classroom type. And it's really geared for people that are first getting into the voice over IP field, the voice over IP industry, or for early startup VoIP providers that are currently having some call quality issues, because those are tricky. So today's agenda is going to be to identify factors which will affect VoIP call quality. We're going to correct call quality issues with RouterOS QoS. We're going to be doing that by marking packets with Mangle, and we're going to be shaping VoIP traffic with queues. We're also going to be detecting VoIP call quality problems, and we're going to check for drop packets in queue views, and we're going to use RouterOS Packet Sniffer along with Wireshark to analyze VoIP packets. And then I'll teach you how to completely avoid a bad situation from even stepping into that situation, so we'll get to that. And so to start, what is VoIP? Well, VoIP is several protocols used together to send and receive real-time voice calls through an IP network or networks. So let's identify some factors that affect VoIP call quality, because that's what we're going to be talking about. So a few considerations to keep in mind about VoIP is that VoIP calls are real-time. So RTP packets, or the voice part of voice over IP, can't be retransmitted. It's got to get there right the first time without any problem. So calls are real-time. Next, the connection between the phones and the VoIP servers must have low delay and even lower jitter. And if you're a company like me, you're going to see that if you're a company like me, my server is actually cloud-based, and we are in 3 data centers across America. So customers' phones will connect to any one of those data centers based on where I decide to set them up. Another thing to consider is you must have enough symmetrical bandwidth for the users, because VoIP is actually symmetrical. So the calls that you make are going to be at 88K on a specific codec, and you're also going to be receiving 88K. So it is symmetrical. So if you have a customer with 1,000 megs of download speed, but only 1 megabit of upload speed, you can only push as much as your upload. Again, it's symmetrical, so keep that in mind. And to do some of the math, you'll see over here, I like to use the G711 ULAW codec, and that's because it's the most widely accepted, and it is one of the standards on the internet for doing that. If you need more bandwidth, or if you want something with better compression, you could use GSM. Here is some of the what the payload is per call. It actually comes out to 87.2K per channel, all right? And that's with 20 millisecond of voice payload per packet. And SIP messages. SIP is the actual signaling that tells the phone will tell the server, make a call, or the server will tell the phone, ring, or transfer a call, or put a call on hold. That's the signaling. So the max SIP message size can be no bigger than 65.5K. So keep that in mind when you're doing your bandwidth calculations. So now let's talk about some problems that we're going to have with voice over IP. Not considering hardware problems, because that's a whole nother ball of wax. And by the way, any tiny little hardware problem will start to affect your user's call experience. I had a bad DIMM card, a little bad memory chip, and it made it appear that there was jitter. So we checked everything, and we're looking at our network, and we're checking for lost packets, and wasn't any, it was hardware. So we're not going to be talking too much about hardware at all, or we won't be talking at all about hardware. We're going to be talking about things related to networking. So what can affect call quality? High jitter levels. And what is jitter? This is what jitter will sound like when a user experiences it. It's not fun. It really frustrates people. But the meaning of jitter is packet delay variation. You could also think of jitter as time lapse between each packet. Another thing that'll affect call quality is packet loss. We don't want any packet loss, so we're going to talk about how to reduce that or prevent it from happening completely. And the last thing is delay. Delay is actually a really tricky one. Delay is interesting because you could have no packet loss, you can have no jitter, and you can still have a really bad VoIP experience. So delay is just what it sounds like. How long does it take for your voice to get to the user's ear? That is delay. An acceptable level we found for delay is anything higher than 200 milliseconds in either direction is going to be a problem. Why? Because 200 milliseconds is roughly a quarter of a second, and humans, we can actually hear that. So the voice that you're saying on the phone, the user is going to hear about a quarter of a second later. So when you're done talking, they don't know that yet. And so you continue talking, thinking that they're not going to respond, they have nothing to say. Then you end up talking over people. The reverse is also true. When someone talks, you don't hear it until 200 seconds later. So 200 milliseconds later. That would be bad.
That's really bad.
Yeah, you don't want that. But if there's no packet loss, no, but that's delay. So delay is actually a tricky one. Yeah, and again, acceptable levels for that, anything above 200 milliseconds will start to be noticeable. People will start talking over each other. Acceptable limits for packet loss is really 0. You don't want any. You could have a little bit really low. I'm talking less than 1%. And of course, jitter levels, that's an interesting one. So we have something called a jitter buffer. And what that does is packets that come in to your voice device, in this case it'll be a phone, they could come in with different levels of jitter, all right? There could be variations in the time between packet 1 and packet 2. A jitter buffer takes it and it actually buffers it for a very short period of time. And then it'll let out that stream nice and evenly. So you're actually, by using a jitter buffer, you're actually increasing your delay, because that's how it works. It introduces delay to even it out on the output. So acceptable jitter levels, we found 50 milliseconds is really the limit. You don't want to go higher than that. Once you start going higher than that, you're increasing your overall delay, and you've already expended what your jitter buffer is going to be capable of. So let's try to keep jitter levels under 50 milliseconds. In the real world, packet loss and delay, jitter packet loss and delay can happen anywhere between the phone and the server. So if your company is like mine, and you're a VoIP provider, your customers will be using their internet connection to get to your VoIP system. And of course, packet loss can happen anywhere along those routes. Luckily, we found that 90% of call quality issues happen at the customer's location. All right, ISPs have done their part to keep their networks nice and clean and really in order and quick with enough available bandwidth. Then what we have to do is we have to start taking care of the customer's end, because like I said, that's where we found most of the problems happening. And why does it happen at the customer's location? Because networks are rarely configured properly, if configured at all, for QoS and VoIP. So keep that in mind. Use a MikroTik. Now let's talk about correcting issues with router OS QoS. So what is QoS? There is no one QoS. QoS is actually a group of techniques that are used to basically categorize and prioritize traffic. And I'm going to emphasize categorize and prioritize, because that's exactly what we're going to be doing, and I'll show you some examples of how to do so. First, we're going to categorize our packets, then we're going to prioritize them. We're going to give them priorities of who has, well, more priority over another stream. Another thing QoS does is it ensures sufficient bandwidth, it controls latency, jitter, and reduces data loss. And I say reduce, because part of QoS, and in this case queuing, is that we actually want to be selective about where we're going to delay packets, where we're going to drop packets, and where we're going to let packets through with no delay or no interruption. So we're going to reduce data loss. QoS will also regulate data flows by classifying, scheduling, and marking packets based on priority and by shaping traffic. This is really just a definition of the other two, because that's what we're going to be doing. We're going to be classifying, which is categorizing. Scheduling is putting them into queues where they're going to be in there for a temporary holding period, almost like a very short buffer until your bandwidth, you have enough available bandwidth and it lets it out. We'll get to that later. So how do we start categorizing packets? Well, in MikroTik world, it's called Mangle. And what is Mangle? Mangle is a router OS facility that marks packets for future processing. So again, first we're going to mark these packets. We're going to categorize them, mark them, and then later on we're going to do something with them. The Mangle marks only exist within the router. That's important to know. These marks will never leave the router. Therefore, it's a MikroTik only thing. It's also used to modify some fields in the IP header like DSCP and TTL. We're going to talk about DSCP a little later because that's important. Another thing to keep in mind about mangling is that you only get one packet mark and one connection mark per packet, and that still is enough to do everything we need to do. So in this example, the technique I'm using is really just to conserve CPU processor or processor time. So first what we're going to do is we're going to mark the connection, and every packet in that connection will then be marked with a connection mark. Then what we're going to do is we're going to use those connection marks as the identifier to do your packet marks. And why is that efficient? Well, because once the session is in connection tracker, all packets for that session are marked. This is more efficient because Mangle doesn't need to scrutinize every packet based on all of your criteria. It just needs to know if the packet is in that connection or not. So we're going to mark the first packet that starts a connection. Then once that connection is in the MikroTik connection tracker, any packet that is in that connection tracker will then be marked with a connection mark, and doesn't need to be scrutinized. So it does save on processor power. So here is my example. My SIP server, 1.2.3.4. It's not a real server, I'm just giving you an example. And the SIP port is your standard 5060 TCP. The RTP port range is going to be the asterisk standard of 10,000 to 20,000 UDP. So this is actually a Mangle rule. And to create a Mangle rule, just go to IP firewall Mangle. Click the add button, you get this. These two boxes are actually the same rule. I'm just showing you different tabs. So on the first tab, the general tab, this is where we actually classify or we're identifying traffic. So the chain is going to be forward because it's for a packet that flows through the router. Then the destination address, of course, 1.2.3.4. The protocol will be 6, port 5060. Now notice on the bottom, hello. Notice on the bottom, connection state. The connection state is going to be new. And that's because we only need to mark one packet in a connection. So I'll make it the first packet. Then every other packet that is in that connection will automatically be marked. So we don't have to process, we don't have to scrutinize every single, what's inside every packet header. Now on the right, after we've classified, what are we going to do with it? In the action tab, that's where you do it. And over here, let me just see, we're going to mark the connection. And I'm going to give it a name. The connection part is going to be SIP connection. Pretty simple. That's what it looks like in the command line. And this is actually what it looks like in your Mangle list. Now that we've marked the connection, let's mark the packet. Okay? And we're actually going to use, again, we're going to use the connection mark as the identifier to mark the packet, hence saving CPU time. So again, the chain is going to be forward, but over here now all we're looking at is we're checking all packets for the packets that have the SIP connection label on it, or the SIP connection mark on it. Then again, you go over to your action tab, and we mark the packet. And I'm going to mark it, I'm going to give it a name called SIP. There you are in the command line, and that's what it's going to look like over in your Mangle list. First we mark the connection, then we mark the packet. Pretty simple. Do the same thing for your RTP. It's the same exact process. The only difference is I'm going to use any port, 10,000 to 20,000, because RTP ports are selected dynamically on the fly, on the source and the destination. So I just chose any port between 10,000 and 20,000. Those values can be changed on your server. All right, so let's see now. Same thing at the bottom. The connection state's going to be new. I just need to mark the first packet in that stream. Then every other packet in that stream is automatically marked. And on the right, the action tab, again, mark the connection. Going to give it a name, RTP connection. There's your command line, and there it is in the Mangle list. All right, and then same exact process. Mark the RTP packet with a packet mark, chain forward. Connection mark is going to be RTP connection. That's all we have to look for now. And again, the action is mark the packet with the word RTP. There's your command line. There it is in your Mangle list. So we've actually just created 4 rules. Even though it's a 2-step process, it does save processor time. Now, you could do this the way I think every beginner does this. You just mark every packet directly. Then you'll only have 2 Mangle rules. But then you're asking the MikroTik, the router, to actually go in and inspect every single packet, every single header in every packet with all the criteria that you're looking for. So you might see an increase in CPU usage. Depending on how much traffic you pass, you may want to do it that way. If you pass a lot of traffic, like I do, you might want to start thinking about saving your processor. So how do we know this is actually working? Well, it's always good to check your work. The first thing we do is we go over to firewall, we go to IP firewall connections. And here's your connection tracker in MikroTik. So if you see over here, that doesn't really work, this pointer. So if you see over here, we have a couple of connections. And if you see all the way on the right, under connection mark, you see SIP connection for 2 of them and 1 RTP connection. So we know that the connection marks are now working because it shows up in your connection tracker. Another way to do this is you could do this in any Mangle rule. Just open up any one of your Mangle rules. I like to choose a Mangle rule that has packet marks, where we're actually, doing a packet mark, not a connection mark, because the packet marks depend on connection marks working properly. So we can go in and we can put a check by the log, and the log prefix, just give it a name so that it's easy to pick out in your log list when you're going and all your logs are flying up. You could just really quickly pick out, I wrote RTP packet. And if you look on the bottom, all the way on the bottom, I've actually pulled out 1 rule out of the log. And you'll see over there in the beginning, I've highlighted RTP packet. And that proves that that is working. Now let's talk about changing DSCP. So what is DSCP? DSCP just stands for Differentiated Services Code Point, otherwise known as DiffServ. It's a field in an IP packet that enables different levels of service to be assigned to a network traffic. This is another way of marking traffic, only this is a standard, and this field in the header is actually going to traverse the network. This is excellent for telling other devices on your network which packets have priority and which don't. Now, in this example, I've actually chosen to mark packets that return, that come back in from the internet. Because packets that come in from the internet aren't going to have any DSCP values. Why not mark them at its first point of entry? So over here again, I create a new Mangle rule. And the chain is going to be post-routing. Post-routing is when the packets get processed after the MikroTik has made a routing decision. Or you could think of it as just before a packet exits an interface. So I chose that. My out interface is going to be VLAN 20, because that's where I put all my phones. And by the way, you should always VLAN your phones. Keep them in a separate network. You don't want them to hear any of the chatter or any of the stuff going on in your regular LAN. And I've seen it where it actually makes a huge difference, so please VLAN your traffic. So over there, the out interface is going to be VLAN 20. Again, remember, it's traffic that comes back into the network. So the exiting interface into the network will be VLAN 20. The packet marks that we're going to be changing DSCP on are the RTP packets, because those packets can't be retransmitted, and we want to give it a high value for queuing. For priority. And if you go over to the Action tab, you'll see that we're going to change the DSCP value. We're going to change it to 46, which is the highest level for DSCP, otherwise known as EF, for expedited forwarding. And this kind of forwarding, this kind of priority is the best for applications that require low jitter, low delay, and low packet loss. So that's how we change DSCP. Next, let's talk about MikroTik queues. Well, now that we have marked our traffic, we have all these marks and all sorts of traffic. Well, what are we going to do with it? Well, we're going to queue it. And queuing in MikroTik queues does all this. I'm only going to be talking about queues, MikroTik queues. One of the things it'll do is limit data for certain IP addresses, subnets, protocols, ports, and other parameters. I'm also going to prioritize some packet flows over others. And the first thing you need to understand about queues in MikroTik world is that we have something called parent queues and child queues. Parent queues are sometimes referred to as inner queues, and their only responsibility is to distribute bandwidth. We also have child queues, otherwise known as leaf queues, and that is responsible for, child queues are responsible for consuming bandwidth. Think of like a parent feeding a child, right? And keep in mind, you can't feed your child more food than you have. Same thing applies here. Over here, here's the queue list, and we're going to be using queue trees. And if you see the parent queue is up on the top of that list, child queues are indented kind of in the bottom as a sub-queue. Now, again, parent queues are only responsible for distributing traffic to the child queues. The parent queue will first try to satisfy the child's queue's limit at traffic, then try to reach the child's max limit. So limit at is your CIR, otherwise known as your committed information rate. And that, let's think of that as your guaranteed bandwidth. Your max limit is how much could you possibly consume for this queue? What's the most bandwidth you could push? So those are two values. Dual limits, as MikroTik calls it. Another thing to keep in mind about MikroTik queues is that priorities are ignored on parent queues. So if anyone here is a parent, you'll know that your priority is ignored and your children have priority. So that's how that works. Same thing here. Also keep in mind that MikroTik has 8 priority levels. 8 is the lowest priority. 1 is the highest. This is a little bit backwards from how you've ever seen it done in COS or TOS, and I actually like this technique a little bit better because you can never have anything higher than 1. 1 is going to be your highest level. Now, MikroTik queues, the queue with a higher priority will have a chance to satisfy its max limit value before lower priority queues. So that's important to understand. And actual traffic prioritization will work only if limits are specified. A lot of times I've created queues and totally forgot to put limits in there, and well, that queue is going to do absolutely nothing because it doesn't know what to do with that traffic. So let me start queuing some traffic, and let me give you the scenario. This scenario is going to be simple. It's my home. I have 5 phones, and my internet bandwidth is 35 megabit download and 4 megabit upload. So to create a queue tree, just go over in your Winbox to queues, and go to queue tree, and then add a queue. On the left, you'll have the command line, but on the right, let me explain what that is. So the name I'm going to call this is just called upload. The parent queue is actually going to be an interface. The interface is going to be Ethernet 1. And that is the Ethernet 1 gateway, which is actually my interface that connects to the internet. So this is my uplink. And that's important to know because queues only work with exiting. For queue trees, only traffic that exits is actually what we're controlling here. So anything leaving Ethernet 1 will be upload traffic. The queue type is going to be default. We'll get to that later. Priority is going to be 1, which is ignored. This is going to be a parent. My max limit, the most I can actually push, is 4 meg. Now, this is where we actually create a child queue. To create a child queue, it's real simple. All you got to do is select the parent queue that we just created, which in this case is going to be upload. Now, here's where we put in packet marks. So remember how we marked packets. Packet mark for this one is going to be RTP. And you could actually add more than 1 packet mark to any queue. You could add several. I just like adding 1 because later on when we're checking for drop packets, if there's only 1 traffic type in that queue and you see drop packets, well, you know you've dropped packets for that traffic type. You don't have to figure out, is this RTP traffic, SIP traffic, TCP hacks? I just do 1 per queue. Again, the queue type is going to be default, and that right there is just packet first in, FIFO, first in, first out. That's how it processes packets for the queue, and that seems to work just wonderful for what we do. The priority is going to be 1. Again, that is the highest priority queue. Now, remember how I said that I have 5 phones, and my house has only been provisioned to support a maximum of 5 concurrent calls. So with ULAW codec, 1 call equals about 88K. So I've set my limit at my guaranteed bandwidth to 440K, because 88 times 5 is 440K. And I've set my max limit to 440K because I never need to go over that. Remember, it's also symmetrical. And you could do the same thing for your SIP packets. The parent, again, is going to be upload. Your packet marks are going to be SIP. And the queue type, again, default, priority. This one's going to be 2. I chose this one to be 2 because my SIP packets are all TCP. If there actually is a drop packet, it'll be retransmitted. Okay, so that's why I did that. And again, the maximum SIP message size is going to be 65.5K. So multiply it by 5, because I can't see there being more than 5 concurrent SIP messages going on at the same time in my network. SIP messages are usually a lot smaller, but I just decided to go with the max. So again, 65 times 5 is 325K. And I've done that for my guaranteed bandwidth and the maximum I could push. You could change that if you need to, but that's how I do it. Now, an important thing to think about is, well, what about packets without any marks? You know, they are still consuming bandwidth. And if they're not accounted for, and if they're not queued, then your queuing and your priorities are not going to really work. Because when does this really start working? This queuing really starts to do its magic when you have maxed out your bandwidth. When your parent has reached its max limit, now it has to start deciding which traffic are we going to allow through first and second and third and so on and so on. So you could think of it similar to like traffic on a highway. Where I come from, the 405 is always jammed. But you know what? We still need to leave some priority lanes for those people that our ambulance, our police, our whoever that need priority to get through in the event of emergency. So think of that as being the priority, and that's exactly what we're going to be doing here. We're going to be selective about which ones are going to go through first, second, third. But packets without any marks still need to be accounted for. So let's create a queue, and again, the parent will be upload. The packet marks, this is actually a default in MikroTik. You will always have the option of a no mark packet. So you would put that in there. The queue type is still going to be default, and the priority is going to be 8. That's the lowest. So in the event of a traffic jam, we don't want to drop RTP packets or SIP packets. We want to drop all the other stuff, your email, your YouTube videos. It's okay to queue that traffic and then eventually drop it if bandwidth doesn't free up. So this is how you do it over here. Now this is what your queue tree list should look like once you're done configuring it. Now notice I also did download. Interesting thing about download. Some people say that, well, it's true that you can't control what traffic comes to your internet connection. But I got to say, most of my customers, if not all of them, don't have any servers that are open to the public internet, like a web server, and they're not serving, you know, thousands of visitors a day or anything like that. So in this case, downloading where the initiated traffic is on the customer's LAN, it's perfectly acceptable. So this is where I've seen really good success with this kind of setup. Next thing is, if you want to be really nice to your customers, you can also prioritize other traffic types like TCP acknowledgements, DNS. You can do that too. Now let's talk about detecting problems. What happens when a customer calls and says, hey, I have bad call quality? Well, you better have an answer. Otherwise, that might not look good to them. So let's check for drop packets. That's the first thing I usually check for before I go into other types of logs. And I enable the drop packets view. To do that, you just go over to your queue tree, and the little drop-down caret on the top right, click that, click Show Columns, then click Dropped. And if you look on the right, you're going to see that we have drop packets exactly where we want them to be dropped. If you see packets being dropped in other queues, well then, maybe you need to resize your queues, set new limits, do another bandwidth test, make sure you have the right kind of bandwidth available to the router and on the internet. But over here, once we see dropping packets in priority 8, that's perfectly normal. Again, we're selective about which packets we want to drop queue and which packets we want to have go through without any issue. I also want you to notice that you have colors over here for each queue. We have actually green, yellow, and red. So green means that you've consumed between 0 and 50% of your available bandwidth for that queue. Yellow means that you've consumed between 51 and 75% of your available bandwidth for that queue. And red means you've gone beyond 76 to 100% of bandwidth utilization. That's when your packets will start queuing. That's when they'll start dropping. Over here you see we have red. That's when it was dropping. I was doing a bandwidth test when I took this. Another thing that's kind of interesting, this could be fun, a MikroTik packet capture. So you've checked for your drop packets. What's going to happen when you actually When a customer calls and says, "Hi, Dave, this is what I sound like," well, you need to find out where that's happening. So first thing you should do, call the customer and start a packet capture on their phone. And actually, I think I'm going to do that right now. Hang on. Just give me a second. I got to set this up. We're going to do a live packet capture with one of my customers. And my cable's unplugged. Hold on. Is this thing supposed to be plugged in? Where does it go? Let's see. Yeah, it's plugged in. I got nothing. Yeah. I got nothing though. See anything that could cause that? Well, I'll go through the GUI. Let me think, and let me try to log into. Could I use Wi-Fi? Well, we're going to use Wi-Fi. Let's see if that helps at all. Okay. Yeah, let's see. All right, this looks all right. Let me share my screen so I could show you what I'm doing. Okay, now let's go over to Winbox. Let's log into this customer. And we'll call them up on the phone, and we'll start the packet capture, if we can download. Okay. So to set up your packet capture, just go to Tools, Packet Sniffer, give it a file name. Also, don't check only headers. We actually want all the payload. We want to be scrutinizing and running statistics on everything, not just the headers. I'm giving this a file name called VoIP.pcap. So now let's call this customer. And you wouldn't want to filter? Sorry? You wouldn't want to filter just for their IP phones or their email? Getting to that. Hang on. You're going to see that in 1 second. Let me just call. Her name is Danelle. And I told her to be next to her phone when I call. So let me put her on speaker. Oh, let me start the packet capture. Hold on. Go over to filter, capture the IP. Oh, that was bad. Packet sniffer and start. Okay, and you see in the file we're actually starting to capture that file. Let's see.
Hello, you have reached Danelle McDermott, Practice Manager for Summit Health Group, formerly Wilkes Family Medicine. So sorry to have missed you.
I'm going to leave her such a good message.
And I'll return your call as soon as possible. Thank you.
Danelle, you know I love you. I just needed you to do one thing. Can everybody say hi to Danelle, please? Hi, Danelle! That's about 100 people staring at me doing a packet capture that's not really going to do much right now, but still love you. I'll speak to you later. It's okay, though. It's okay because we actually did capture the RTP for that, and let's stop the packet capture. So... No, actually the server picked that up. It never made it to her phone. So we didn't capture anything. But let me show you with a packet capture that I've already pre-captured. Just in case someone is at their phone, isn't at their phone. So if you see over here, I have one called Kyle-VoIP.pcap. I've captured this earlier. And if you open it in Wireshark, come on, Wireshark, there you go. First thing you do is filter out the RTP stream. And it is case sensitive, so do RTP. RTP, hello. RTPO. Okay. And then just pick any packet in this stream because, well, it's only going to be for the phone that we've targeted. Then what you do is you go over to telephony, go over to RTP, and then go to stream analysis. And this is actually some really good stuff. This is where the magic happens. Over here, you can see your max delta. You can see how many packets you've passed. You can see how many drop packets you've passed over there where it says lost RTP packets right here, sequence errors. Any packets that don't come in sequence are automatically dropped. So if you have a customer with an issue, you're going to want to do one of these. First, check for drop packets in your queue views, then do one of these. Another thing that's really nice about this, and I'm going to build on this later, is that you see how you have the player button right there? Well, the player button's nice. You can actually replay this RTP stream. I'm going to do that right now. Just click decode. Pick the legs that you want to actually play. We're going to play both directions. And now, we're going to, did I already click decode? I'm going to click play. Listen.
All right. So everything sounds excellent.
Well, I can't get it to play on the, I can't. Well, I have a mic, so I have an external speaker that I've actually brought with me just for such occasions, which I can't find right now. But, well, let me try to play it again. Hold on.
Alright. And then I'll play it for everyone just in case the live packet capture doesn't work. You always need a backup plan. Most definitely. Never know about.
And that's how you can actually capture a packet, capture a SIP stream, RTP stream, play it back to the customer. This is important. You could do this real time if you don't have any type of special software. All you need is Wireshark and the MikroTik packet capture, and it works great. And again, run those statistics right here. See what's going on. Lost packets, look for your jitter levels, your mean jitter, your max jitter. So over here is going to give you that kind of information. And this is something everybody should have access to. Wireshark is free. Let's go back to the presentation, and where did I leave off? Oh, look at that, we're from the beginning. Let's see how fast I can click. Okay, so we saw that over here, the RTP, pick it out, play it back, and that's good. Now, this is how to avoid problems, avoid getting into a really nasty situation. First thing is, be selective about who you take on as a customer. Make sure their internet connection is adequate. And I'm not just talking about bandwidth or symmetrical bandwidth available, because I actually have a customer with only 1 meg of upload speed, and they are flawless. But before you take on a customer, do some very basic, kind of a monitor on their internet connection. I use Zabbix, and I just do a simple ping to their server. But with the response from the ping, I am testing those things that will affect call quality. I'm going to be testing jitter, packet loss, and latency. Okay, and this is actually a graph of a customer that I had to tell, sorry, I can't help you. Don't get VoIP from me, don't get it from anyone, until you either change your internet connection or correct any problem that it has. Unfortunately, he could only get a T1 where he is, which was oversubscribed and really wasn't that great to begin with because of the location that he's at. If you see over here, this is actually measuring jitter. And if you see, his jitter goes way beyond, well, not way beyond, but it goes above 150 milliseconds, which is really the danger zone. I don't want to take any customer that has more than, let's say, 50 milliseconds of jitter. And why? Well, because once you do all your QoS and everything, you could reduce this to a certain extent, but you can't eliminate something like this. This is just too much. So I told him, and he's actually, I know him very well, CPR Industries in Southern Cal. Huge company, but VoIP is not for him. So be very careful. You don't want to sign up a customer. You don't want a salesman going out selling someone that has an old DSL line because they live in Timbuktu and their connection is not adequate. Salespeople will do that. They'll sell anything. They'll get the IT people to install stuff, and then when it comes to go live, all of a sudden customers are like, oh, everything doesn't sound right. I'm getting jitter, I'm getting packet, I'm getting call drops, I'm getting all sorts of stuff, and then you're like, well, go speak to your ISP. And that's when the finger pointing starts. And don't get in that situation. Because try explaining to a customer what jitter is. When you tell them it's your internet and they say, well, I could browse. Bad situation. Stay away from that. All right? So I think some of us have been there. But but really, that's one way we do it. It's also a good idea to monitor the latency or the delay and to measure packet loss. Again, don't just do jitter. Do those three things. You know, show the customer, hey, this is what we're monitoring, and you look like you're good to go with VoIP. And by the way, this will build trust. And let me tell you, I have not lost one customer to date since I started my VoIP company because I take care of my customers this way. You should too, and you'll see they'll be loyal. And actually now they start calling me up asking, hey Dave, I can't load this web page. Could you take a look at the monitoring? And so they start asking you for also what just happened. They start asking you for all sorts of stuff, which is a good thing. So to avoid problems, you could also do, you could capture every call that ever goes through your network. You could get that in a PCAP. There's a free software out there. It's open source. It's called sipcapture.org. I highly recommend it. And what this will do is you will send a data stream of your server for all the RTP and SIP, kind of mirror it to your SIP capture server or VPS, whatever, and it will capture everything. It'll put it into a packet. It'll run statistics on the call. It'll do some of those statistics for you. So if you have a customer that calls up and says, hey, I called someone this morning and it sounded awful, then you could actually go back to that call. You could look at the statistics for that call. You could replay that call if you want. Some HIPAA people are a little bit about that. But you could do that, and it's going to show that you really do care about the customer and you care about their call experience. 9 out of 10 times when I do this, it turns out the person on the other side was on a cell phone in the middle of nowhere. And I say, hey, by the way, this looks like it might be a cell phone because I don't see any packet loss. I don't see any jitter on your side. But even then, that's not enough. Everything could be perfect, and you could still have problems, and the other person could be on a landline. And when does that happen? It's rare, but it does happen. It actually happened a few days ago between Verizon, which is now Frontier in California, and Cogent Networks. So you can go to Internet Health Report, and it will show you all the major carriers, the backbone carriers in America, and who they peer with. And if there is a problem, like over here we have between Verizon and Level 3, if there is a problem and you've checked everything and you showed the customer that you've checked everything and everything looks good, but hey, this call is going to a carrier from my server to the carrier and it's taken a route that's going through one of these bad connections. Good news about this is that carriers usually take care of their problems almost immediately. They are really fast about this. So you show them everything and they build trust and they trust you and then they're calm. When you don't have an answer, oh, that's when you're in very big trouble. When you say, I don't know, let me open a ticket. You know, that I don't like hearing that when I call my carriers. I want them to know right away. And when they say, hey, there's a problem with this and that, and okay, cool, how long? Can't give you an exact time, but we know in the past they've solved their problems within 20 minutes, 30 minutes, whatever. So that really, really is a huge thing. Use those three things, check for lost packets, do your packet captures, and also check the internet if all else fails. See what's going on. So to summarize, we've learned about some factors that'll affect VoIP call quality. We've learned how to reduce or eliminate call quality issues using queues, and we've learned how to find issues and diagnose issues with Wireshark, and we've learned how to avoid a bad situation altogether. So that concludes the presentation for today. Are there any questions?
Thank you. There are a lot of questions. Okay, let's start.
The first thing we do with our SIP systems is to turn off the SIP helper in MikroTik. How do you work with the SIP helper?
I didn't hear you, what?
How do you work with the SIP helper in the MikroTik system?
I completely turn it off. I do, and it works. And I'll tell you what happens. When the way to check that is go into your asterisk box and do a SIP show connections, and you'll see what the WAN connection it's seeing, and also what the internal IP that phone or device is reporting. When you see both of them are your WAN, you'll know right away that you have a session helper problem. So turn it off immediately, and all of a sudden you can see the internal, the external, and everything will work fine. I do that by default, by the way, for all my customers, automatically turn off SIP.
How does MikroTik respond to that?
Yeah, uh-oh.
Come and ask us at the registration table.
The truth, though, is it just works. It works. So just turn it off, it works. And it's going to vary based on what kind of network you have, what you have in your data center. Are you running that? Are you not running that in your data center? I don't. Is the customer running that? They should, most of the time. But it does its job. Next question.
Okay, so more than the technical approach you would take to engage the customer. You say salespeople, they know how to sell. So basically, how would you engage or try to solve the problem with a person that tells you, well, you're talking about jitter. What's jitter? It's not yiver yabber? So what would you tell a customer that is constantly telling you, I can hear my peer, I can hear the voice of my peer, and how do I solve it? How will you take the approach to talk to, let's say, an end user? And one sub-question, RTP?
Yeah.
Shouldn't it be SRTP or TLS? Shouldn't it be secure? Thanks.
That's just the signaling. You could make it secure if you want. I don't. It makes no difference to me. If anything, if you want to be HIPAA compliant, I heard a couple of questions in there, but if you want to be HIPAA compliant, the only thing you have to encrypt is the voicemails that you store. HIPAA compliance only talks about stored patient information. You could encrypt your SIP messages. You could even encrypt your RTP messages. It's just going to put a bigger load on the server. But the question you said also something about salespeople. How do you tame a salesperson?
No. How do you engage with the person, the customer? How would you talk to the customer and have them understand jitter and all of the technical jargon?
Easy. I actually take a deck of cards with me, and each card represents one packet. And so I start putting packets on the table, all right? And then I stop and I make a delay. And then comes the next packet, and then the next packet, and then a quick stream of packets. And I say the time between packet 1, packet 2, think of that as your packet delay variation. And then I talk about jitter buffers, but that's only if they have an IT department. A regular customer, what do I tell them? I say, just sign here, everything will work. You know, and that's it.
Hi, you showed using Qtree for doing voice. What about using simple queues?
Simple queues. Simple queues are interesting. I've always used Qtrees. I like to use Qtrees because Qtrees offers one direction, whereas simple queues, it could be both ways. So it actually eases Mangle configuration. I don't have to make Mangle marks or packet marks for upload traffic and download traffic, so it cuts my mangling in half. And Simple Queues has a couple of other features, like you could do it based on time of day. I don't ever want to do that. What else? Simple Queues. Qtrees is just what's worked for me always, and I'm doing it based on protocol, not by IP address or anything else.
Okay, thank you.
Also, if you want to use simple queues and you have a long list of queues, you know, the traffic has to go through each queue one at a time. With Qtrees, boom, it happens all at once. So a little bit less on the processing if you have a lot of queues. Next question.
When you set your max limits for your child queues, is there a benefit to setting the max limit to your maximum connection bandwidth, or should you guarantee that to 440 kilobits, whereas if their download connection was 10 megabits, could you set the SIP and RTP max limits to 10 megabits?
That's actually an interesting question. Good measure for setting up queues is that your max limit for your children of a parent do not exceed the max of the sum total of your child's queues don't exceed the max limit of your parent. I was asked this by a friend of mine saying, well, how do I do dynamic? I don't just want to allow this much bandwidth for this type of traffic. Let's say HTTP traffic. Let's say I want to allow the max, but when we're not using that max, we want something else to take its place. I am experimenting with that. We're just setting all of the max limit to the max limit of the parent and see how that works. I haven't messed with that too much, but I'll experiment, and we could do it maybe after, and I'll tell you what kind of results we get. I'm just going by what MikroTik says to do and what's suggested to do, so that's the best I could tell you with that.
Okay, thank you. Next question.
We've got about 30 Asterisk servers running. Recently, about 6 months ago, we started using VPNs. We were doing all of the queuing that you were doing up there, but all of our queuing, all of our QoS went out the window when we started using VPNs, and you can understand why.
Yeah, that's actually a good question. The first thing you should do is find out what your maximum segment size should be. If you're going through a VPN, you may want to lower your maximum segment size, because VPN will take some of that overhead. What's the question, though?
We also changed, for internal reasons, we changed the packets from UDP to TCP because we're using some special software on the Asterisk servers to do SIP signaling. We're using it on BLF. We're using on the old Cisco phones, the 7961s. We're using it like a key system instead of a straight PBX. So we had to change it to TCP.
And your question?
The question is the QoS, once again, went out the window.
I'd have to look at your configuration. There's too many variables. One thing I'll tell you that I swear by is the RTP. I always make it UDP, because you can never really retransmit voice. It would be like taking words from the beginning of my sentence, adding them at the end because it's been retransmitted. Always use UDP. And also do your logging. You know, the key to finding any answer to any problem is do your logging, do your packet sniffs, all right? And analyze it in Wireshark. See exactly what's happening. It could be one of a number of issues. It could be something with NAT, it could be something with the MSS. You really, there's a lot. You can speak to me after and we could go through some of those things.
Okay, thank you. Do we have any more questions? Yes.
Can you show what you did in Wireshark one more time real quick? Because you were very fast, like a ninja.
That's what they call me, the ninja. Am I still on screen here? Good. All right. So after you've captured your packet, do you want me to show you, where are you? There you are. Do you want me to show you just MikroTik packet capture, or you want me to show? Okay. After you've downloaded your packet, your PCAP file, like we have right here, just open it in Wireshark. All right. There's going to be some other stuff in that stream, so you could just filter it out by RTP. And again, lowercase RTP. And then apply it. And now these are all the packets for RTP. Click on any one, because this is only going to be for that phone. We don't have to go and sift through which RTP stream was for which phone. And I'll show you another nice little shortcut on how to do it this even easier. But I want to show you the statistics screen. That's why I showed it this way. So after you've filtered out your RTP, click on one packet. Could be the first one. Go to telephony. Go to RTP. And go to stream analysis. Take a pick. Come on. I'm going to photobomb it. Go ahead. All right, good. So then after you click stream analysis, here you go. It's not only going to list every single packet, it's also going to list some information about your capture. So, for example, the things that I look at is total RTP packets expected this many, lost packets, sequence errors. Right there, lost packets and sequence errors is going to be most likely indicative of a QoS problem. Let's not assume that there's a problem on the internet, but you're going to look here. You could also see the kilohertz that was recorded in. You could see how much actual voice payload was in per packet. You could tell the time difference between packets. So that's how you use Wireshark for that. And then again, you could just go over to the player, decode, and then put a check for both legs, the called and the caller, and then just click play.
Hey, what's up? Hey. All right.
I don't know where the mic is on this damn thing.
Let's day. Very good, and I'm capturing this in a packet capture on the MikroTik.
So that was with me and my friend, just for in case this. I also want to show you a quick another way to do this, and this is nice. If you just feel like capturing all packets from a customer's LAN, right? You don't got time, you got to do this quick. I'm having the problem right now. You jump in, do your sniffer. I would say just go to, let me clear this. I would say go to telephony, then go to VoIP calls. This is nice. And you could also see the SIP conversations if you do it this way. Go to VoIP calls. Now in this case, I only have one call. But if you had 10 people on the phone, you would see 10 SIP conversations here. Some of them might not be complete. The status over here, the state for this one is completed because I started the packet capture before we made the call. So it's got its invite and its goodbye message. But if you capture a call, in the middle of a call, it'll say in progress. And then over here, once you have this, the cool thing is you can actually click on flow. Whoa, we crashed. So let's try that again real quick. We go to telephony. We go to VoIP calls. Come on, there you go. It's going to actually find all the VoIP calls. You're going to go to flow, and we crash again. Well, if you click flow, you'll actually see the SIP messages between the phone and the server. It'll give it to you in a nice, when you see it, if you're a VoIP person, you will recognize it. And by the way, that is an excellent way to tell when a call dropped happened, because the buy signal is either going to come from your server or from the customer. So when a customer says, and this happens to me, I mean, I get every single crazy idea someone has, they always throw it at me. So I had a customer that said, I keep getting call drops. All right. I pull up my stuff in SIP capture and I look at the SIP conversation, and then I'll go look where did the buy signal come from. Sometimes it comes from the customer's phone, meaning they clicked buy. They clicked something, oh, I forgot I didn't put them on hold, I actually hung up on them. So that's another great way to troubleshoot SIP problems when it comes to call drops. Any other questions?
Okay, cool. Thank you. Let's